This is day 19 of Unit 7. We started today with this warm-up, so take a moment and pause the video to try the warm-up and then play to check your answers. So the question asks to find the inverse, so I'm first going to just do so algebraically. Y equals the square root of x plus 5, so I know subtract 5, square both sides. I'm just going to leave that as a binomial squared. I'm not going to take time to square it. And I know that I'm squaring, so just x. And then interchange x and y and make it f inverse of x. So f inverse of x is equal to x minus 5, the quantity squared. So that's the algebraic piece. Hopefully you didn't just stop there and say that's your answer because of yesterday's lesson. So if you recall, yesterday we talked about when the problem is dealing with even roots or even powers, which this one is, you have to check to see if there's any domain restrictions required. So we're going to do that before we circle that and say that's our final answer. So I'm going to think about the sketch here of the original. So the square root of x, I know that's the positive part of a square root. So a parabola on its side, the positive half, and then up 5. So 0, 5 is the vertex of that graph, and then I know it's going to be the top half of the parabola on its side. So I know that's the original graph. If I take 0, 5 and flip it, I get 5, 0. And again, the positive half of the parabola on its side is going to be the positive half of a regular parabola. So I know that I want y equals the quantity x minus 5 squared, which is 5 to the right, which is what I have, but I don't want the full parabola. I only want the positive half. So I have to indicate that I only want the positive half of this parabola by restricting the domain of the equation. So I'm looking here, I know I want from the vertex to the right, so the vertex is at x equals 5, and I want greater than that, so my restriction is comma x is greater than or equal to 5. That is the equation for the inverse. And by the way, in the homework you had some questions that asked whether that was a function or not. This graph, this inverse, is a function, and I know that because we talked earlier, and you know from Algebra 1, we do a vertical line test. This passes the vertical line test. So the inverse is a function, and the original was also a function. Okay, so then I had you, next we turn to page 6 in your packet. So this is page 6, and we played a little game today, and the game was, you can't talk, you just have to figure out the pattern. And just a couple things before we start. So I had students fill in these stars here for 0, -1. The double stars mean undefined. So we won't be filling any values in for those. The single stars, go ahead and put those in for 3 and for 0.2. And the single stars mean we're going to have to use guess and check. Okay, so we'll save those till the very end. So basically the game is you have to figure out the patterns that you're noticing between these numbers. So 8 and 3, 1/2, -1, any of the ones that are filled in, 1 and 0. Figure out the pattern. You can use a calculator to help you, but see if you can figure out what the pattern is, and then if you think you have the pattern, you should be able to fill in the ones that are blank. And can't talk about it with your classmates. Just silently try and figure out the pattern. So if you're at home watching this and you weren't in class, I would suggest pause the video for a couple minutes, see if you can figure out that pattern without me telling you, and see if you can fill in the table. Then play to check your answers and go from there. Okay. So I'm going to go over what you hopefully just figured out if you were doing this on your own. So the pattern is there is a relationship between 3 and 8, negative 1 and 1/2. And the reason I'm going in that order, that's kind of backwards. Normally we have input being the x and the output being the y. This is reversed. And hopefully after looking at the numbers, you started to realize that. We know 8 and 3 are related and 6 and 64, they're related because I had you memorize those exponents, and you know that these are all powers of 2. So 2 to the 3rd power is 8. 2 to the 5th power is 32. 2 to the 4th power is 16. 2 squared is 4. 2 to the 1st is 2. If you think of this as 1/4, we know that's 2, the negative 2 power, 2 to the negative 2 power. And this one is 1/2 because 2 to the 1/2 is the square root of 2. And lastly, negative 3 because 2 to the negative 3 is 1/8. So those are all the ones you should have gotten initially. We got those first, and then, like I said, after we kind of, most of us in the class realized the pattern, then we started figuring out the other two with the double stars or the single stars using guess and check. So after typing your calculator, we realized that 2 to the negative 2.32 gives us approximately 0.2. And 2 to the 1.58 approximately will give us 3. So now we have our table filled in. The next thing you're going to need to do is in your notebook, set up a large coordinate plane, taking up most of the page, and then put the origin in the center of the page. And then what we'll do is, once you have that set up, we're going to go ahead and plot the points from the silent board game table. So I'm going to do that now. So we have, and I'm going to only plot the ones I can. Some of these big numbers I'm not going to be able to plot, but 8, 3, I can plot that right there. 1/2, negative 1, right there. 32, 5, can't plot that one. 1, 0, I can plot. 16, 4, I can probably approximate it. I'll just put it down there. Let's see, what else? 4, 2, yep, I can plot that one. 4, 2 right there. 3, 1.58. 1.58 right there. 64, can't plot that one. 2, 1. 1/4, negative 2. Let's see, 0.2, negative 2.32. Right, about there. And 1/8, negative 3. All right, about there. Okay, so what we're hopefully noticing is as we're getting closer and closer to x equals 0, the graph is going down, but it's never going to reach x equals 0. So hopefully you're seeing that with the curve that we're starting to graph here. You're seeing that curve. Oops, didn't mean that bump there. Seeing that curve, you're realizing hopefully that there is a vertical asymptote, and the vertical asymptote is x equals 0. Okay, so we have that graph. So the next thing we're going to do is it asks us to graph. Oh, I was going to mention something else, sorry. So if I go back to my table a minute on the previous slide, so 0, remember we said is undefined. That's another reason that we know that there's a vertical asymptote at x equals 0, besides the fact that it looked like it based on what was happening on the graph. But we also know there's a vertical asymptote because we know from the table that the 0 value is undefined. Okay, so next it asks us to graph y equals 2 to the x. So from our previous work earlier in this unit, we know that's an exponential graph. We know the base is 2, so it's going to be increasing exponential. And we know that there's no number on the end, so we know that the horizontal asymptote is y equals 0. All of that I know before I even start doing anything. I am going to go ahead and make a small table just so I can get a few values. Substituting 0, I'm getting 1. Substituting 1, I'm getting 2. 2, I'm getting 4. Hopefully you're following me here. This should be pretty quick. Negative 1, 2 to the negative 1 is 1/2, 1 over 2. Negative 2, 2 to the negative 2 is 1 over 2 squared, which is 1/4. So I'm going to just plot those. 0, 1 right there, 1, 2 right there, 2, 4 there, negative 1, 1/2 there, and negative 2, 1/4 there. And I know if I kept going, it would just get closer and closer and closer to the x-axis, which means there is definitely a horizontal asymptote at whoops, y equals 0. The x-axis, y equals 0. So I'm going to make my curve increasing exponential. And hopefully you're realizing as I'm plotting that, as you're plotting yours, hopefully you are definitely recognizing that that is the inverse of the graph we graphed. And I'm going to go from the silent board game. They are definitely inverses. How do I know that? Well, first of all, just visually, I can see that the original graph from the silent board game, if I fold it over the line y equals x, I am getting this graph y equals 2 to the x. The other way that I can tell is by looking at the points. Every single one of those, 0, 1 is 1, 0 on the other graph. 1, 2 is 2, 1. So again, that's how I know that these two graphs are inverses. Now, we did do the graph in part 2 on page 6, but we didn't do part 1 yet. So let's take a moment to do that now. So the pattern that we described, or I described a minute ago, is that for number 1, I take 2 to the power of g of x and I get x. So then part A asks for the rule or the equation. The equation would be 2 to the g of x is equal to x, or 2 to the y is equal to x. So I'm going to go ahead and add that as a label to my graph here. 2 to the y equals x. And again, that's another way that we can tell that the two equations are inverses, because if we look, x and y are just flip-flopped, okay, which we know is true about inverses. So now we have our equation. Now, the only problem with that equation is it's solved for x, not y. We always have equations that are solved for y. So we're going to talk about here in the next minute or so, we're going to talk about how we can get that equation solved for y, okay? And so in order to get that equation solved for y, we have to use what are called logarithms. This graph, graph that's this shape with the vertical asymptote is called a logarithm, okay? So logarithms are inverses of exponential functions. So we already know what exponentials look like. Now we know what logarithms look like. So when you're asked to graph a logarithm, it's going to look like that shape, okay, which is the inverse of an exponential graph. Okay, so now in order to answer part B and part 3, we're going to have to rewrite this equation, 2 to the y equals x. We're going to have to put it in log form. So I need to explain how to do that. So this is currently in what we call exponential form, where we have a base and an exponent and equal to something. Now, in order for me to get it solved for y, I have to put it in log form, which means I'm going to start by writing the word log. Log is short for logarithm. So I write the word log. Whatever the base is in exponential form, it's also the base in log form. And the way that I write a base or indicate what a base is in log form is by using a subscript. So if you have chemistry, you know what I mean by that. It's written small and lower. So the base, 2 in this case, just is written a little lower and smaller. And then I'm going to have parentheses because we're taking the log base 2 of something. And that's how we read this, log base 2 of, and then whatever I have written there. And that's going to be equal to, and then we're going to put something over there on the right side of the equal sign. So that's the general setup for logarithms. Log base 2 of some number is equal to some number. So now here's what we're going to do. And the way that I'm going to show you a technique that makes it pretty easy to go from one form to the other. It's a little circle that we create. I like to do this because I think it makes it easy. So we're going to start with the base, which is 2, which I've already written. And I'm looking at exponential form as I'm doing this. So I know 2 to the y. So I go start at the base, 2 over here, and that's where I put the exponent. Okay, and then I need to create a circle, so I have to come back over and put what it equals in that section there, in that spot. So that's x. So 2 to the y equals x. I created a little circle there. That's the same as exponential form. So now we have log form, which we read this as log base 2 of x equals y. Log base 2 of x equals y. So now we have log form. So now that I have log form, I'm going to add that to my graph because not only is it log form, but we got what we wanted. Now it's solved for y. So y equals log base 2 of x. And now we have our equation in y equals form. So now that we have our exponential equation and our log equation solved for y, now we can see that logarithms and exponentials are inverses. Okay, so we have our equation for the inverse of the exponential. All right, so now we're ready to move on to, I want you to put these in your notebook. We're going to just get some practice on going back and forth from one form to the other, because that'll become important over the next several days when we use logarithms more and more. Today, you're not really understanding why you're doing this, you're just understanding how to do it. And again, over the next several days, I'll get into the why we're doing this more. So I'm going to copy the base. Well, I'm going to write the word log first. I'm going to copy the base of something equals something. So again, you might want to use the little circle trick I showed you. So 2 to the what power, that's a 4, is equal to 16. So in log form, log base 2 of 16 equals 4 is the same thing as 2 to the 4th equals 16. So 3 to the x equals 11. Take a moment, try it. So the base is 3. So 3 to the x equals 11. So log base 3 of 11 is equal to x, is the log form of 3 to the x equals 11. Now that little circle trick works if they're in log form and we want to write them in exponential form. So again, I'll start with the base and I'm going to copy the base 3, and then I go over to the other side of the equal sign for the power, so that's a 2, come back over, and that's what it equals. 3 squared equals 9 is the exponential form of log base 3 of 9 equals 2. And lastly, this one, so 8 to the k is equal to a. Hopefully that's pretty easy for you to do. Okay, so now that we're able to rewrite in the alternate form, now we should be able to answer the rest of the problems on this worksheet on page 6. So we have number 1b, which says g of 1024. So before we're able to answer that, I want to remind you of what our equation was, because this is, when it's asking for g of 1024, it's referring to the equation we came up with. Well, the equation we came up with a moment ago was g of x equals log base 2 of x. We wrote it as y equals, but remember, g of x and y are the same thing. So if I'm asked to find g of 1024 and I know g of x, the question is, are they replacing x with 1024 or are they replacing y with 1024? Hopefully you're able to see that the x is what got replaced, which means in my equation I'm going to put 1024 in the x spot. So let's do that. So log base 2 of 1024. So in other words, what we're going to do now, I don't know what that equals, so I'm just going to put a question mark. So I have question mark is equal to log base 2 of 1024. So in other words, if I do the circle, 2 to the question mark power is equal to 1024. Now, if you don't know that one off the top of your head, you can just type it in the calculator. You're going to realize that 2 to the 10th is 1024. Which means that, go back up here, log of, or g of 1024, well, that equals 10, because 2 to the 10th equals 1024. Okay, so next, you should try the problems that are similar to that. So similar to g of 1024 would be part 3, letter A. So go ahead and look at that, give that a try. So g of 32. Same idea, we're going to rewrite, we're going to replace x with 32. So log base 2 of 32. So that's going to equal, I'm just going to use question mark again. So 2 to the question mark is equal to 32. Well, we know that that is 5. 2 to the 5th is 32. So that means the log base 2 of 32 is equal to 5. Okay, so take a moment to try parts B, C, D, B, C, and D. B, C, D, and I, actually. B, C, D, and I. Pause the video, and then I'm going to go over those. Parts B, C, D, and I are just like the two that we did here. Okay. Okay, so now that you've tried those, let me just go over the answers. So B says G of 1/2. Well, that means the log base 2 of 1/2. Well, we know that 2 to the negative 1 power is 1/2. So log base 2 of 1/2 equals -1. C, G of 4, same idea, log base 2 of 4. Well, 2 squared equals 4, so log base 2 of 4 equals 2. D, I want G of 0, whoops, G of 0. So log base 2 of 0 is equal to, well, 2 to what power gives me 0? I can't take 2 to a power to get 0, so G of 0 is undefined. And lastly, I ask you to look at I. I says G of 8. So log base 2 of 8. So 2 to what power equals 8? We know that's 3. So G of 8 is 3. Okay, so that takes care of the first several that where we know the x value. Now let's take a look. I'm going to extend my page here. Let's take a look at the other type of problem in part 3, which is when we're given the y value. So like part E, let's say. So G of x equals 3. So remember our equation, G of x equals log base 2 of x. So when they're saying G of x equals 3, I'm replacing the y value, or the G of x, with 3. So I'm going to do that. And again, I can use the circle. 2 cubed equals x. Therefore, x is equal to 8. So once again, pause the video, try F and H. Looks like I skipped G. We'll go back and get that in a minute. But try F and H because those are similar to E. So pause the video, try those. So F, G of x equals 1/2. So G of x equals log base 2 of x. So I'm putting 1/2 in the G of x spot. So 2 to the half equals x. Well, I know 2 to the half is the same thing as the square root of 2. So x equals the square root of 2. That was part F. I also asked you to try part H. So G of x equals 0. So 0 equals log base 2 of x. So 2 to the 0 is equal to x. Well, 2 to the 0 is 1. So x is 1. Okay, the last one that we didn't do yet, we skipped G. So let's go back and look at G. I'll put it back here because it was when part G is, we know the x value. So G of 1/16 means log base 2 of 1/16 is equal to whatever. So 2 to what power gives me 1/16? Well, I know 2 to the -4 is 1/16. So the G of 1/16 is -4. Okay, so that takes care of all the problems we did in class today. I think I did, with at least some of my classes, I did go over one other thing. You'll see in the homework some questions that say something like evaluate, and then it'll have a log. So let me just give you an example. Log base 3, let's say, of 27. That's very similar to what we did over here when we knew the x value. So like log base 2 of 1/16, I didn't know it equaled -4 yet. I said 2 to what equals 1/16. Same idea here. I don't know what this equals yet, so I'll just use the circle trick. 3 to the what power equals 27. Well, I know that 3 cubed equals 27. So when it's asking you to evaluate, it just means tell me what it equals. And the log base 3 of 27 is equal to 3. Okay, so that's what you'll do on the questions that say evaluate. Okay, that takes care of our lesson for today. So your assignment for this evening is pages 7 and 8, and then also page 14. Tomorrow's Pi Day, so if you want to bring something round in to eat, that would be fine. And then you do have a short quiz coming up on Friday.